All right, the first question we got in chapter 5 is 5.3, 43/14. 5.3, 43/14. And this one says, a pharmaceutical company receives large shipments of aspirin tablets. The acceptance sampling plan is to randomly select and test how many tablets? 17. Then accept the whole batch if there is one or none that doesn't meet the required specifications. If a particular shipment of thousands of blah, 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 blah actually has a 3% rate of defects, what is the probability that this whole shipment will be accepted? All right, so a pharmaceutical company, large shipment of aspirin tablets is accepted to select and test 17 tablets. So take a second and write that down.
Which number is it?
Thank you. You didn't bring me no lunch, so I'm not talking to you. All right, take a second and go ahead and try to work it. So this is 5.3. Did I say 5.3 or 5.2?
5.3.
Okay. So that is, I think, NP and X, the formula, NP and X. Now, of course, hopefully you don't have to use the formula, but we'll write it down just in case. So, N, what have I always told you about N? It will always be the what? Biggest number. And where's the biggest number? 17, so that's simple. P is always going to be a what? A percentage. Percentage is another way of writing what? Decimal. Or you can write this 0.03. That takes out that number, and that takes out that number. So we're looking for another number. Well, where is the only other number in the whole problem?
1,000.
One or what? None. So X is going to be 0. And then you're going to take this guy and put it in NPX. And then you're going to add it to N is equal to 17, P is equal to 0.03, and X is equal to what? 1. Now add those two up. No one wants an easy reply. Oh. So, second.
Mine won't let me do the 0 one.
It should.
It says error domain.
Let's see what mine does. I don't know. Second function. I'm sorry, second bars. Binomial what, PDF? Is that the one? And then you're going to type in n, comma, 0.03, and 0. Should.
Okay, I got it.
Huh?
I got it.
So let's take our handy dandy calculator. And there's our calculator. And second, bars, dang old 0. And then 17, comma, 0.03, comma, 0, close parentheses. There's that one. So I'm going to store that, stove, where you buy your bread. And I'm going to say alpha, call it first. I use first a lot for F. There's that. Then second entry, and then type in 1, and stove, alpha, S for second number. And now we take the first number, alpha F, and times the what? Second number, Hubert. That's right, class. I'm sorry, plus. You're right, thank you. I'm still not talking to you. And enter. I got 0.909. That should be your answer. Ta-da! That's it. Alright, so to make sure everybody's got it, let's do a nerd. This one says, a pharmaceutical company, blah, 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 randomly select and test 29 tablets, then accept the whole batch if there is one or none that meet the required specification. If a particular shipment of thousands of aspirin actually have a, cover it up where y'all can't see it, 2% rate of defects, what is the probability that this whole shipment will be accepted? Well, we're going to do some changes here. And those are the changes right there. So our new N is what? 29. And our new P is 0.02. Now you do the same thing. Get your handy dandy calculator out. Clear. Second entry. And this is just if you want to use the second entry. 29. 0.02. And 0. I got 0.5566. Stove, alpha, F, enter. Second entry, and change that to 1. Stove, alpha, S, clear. And now alpha, F, plus alpha S. dang old point, 8860. So we type that in, and we feel good about ourselves. It's a good test question. Why? Short and sweet. And it doesn't take much to get it what? Right. Alright, we good? Alright, let's try nerd. Next one. 5.3, 25/10. 5.3, I done forgot it, /10.
26.
Thank you. It's 26/10. Whatever. Refer to the accompanying technology display. Excuse me. The probabilities in this display were obtained using the values of n is equal to 5 and p is equal to 0.753. I wonder what those are going to be used for. In a clinical test of a drug, 75.3%, that's the 0.753, of the subjects created with 10 milligrams of the drug experienced headaches. In each case, assume that 5 subjects are randomly selected and treated with 10 milligrams. Find the probability that more than one subject experiences headaches. It is reasonable to expect that more than one will experience headache. Is it reasonably? I don't know what this is. Okay, there we go. All right. Now, this is very important because a lot of people, they read this sentence right here and they just sit there and stare at it. And there's nothing wrong with that because a lot of people get confused with more than and at least. All right, so you need to think. What does more than one mean? That means any number above what? 1. So what you do is you take your handy dandy highlighter and you highlight all of these guys. What should you do before you start this problem? What? Exactly. Because all of them are between 0 and 1 because there's no 1.2, 2.2, 3.3. There's none of those. So you got to add them up and check to make sure they're what? They're equal to 1.999. 4 nines are 1.00001. So check them. Somebody tell me if it's equal, if it's okay or not. Okay. All right, so the next step is the probability, the more than one subject experiences headache. Is that the easiest way to do it? No, it's not. There's another way that's a little bit easier. What is that? Yes, you can add them all up and get the answer, but what's the other way you can do it? Starts with a C. O. M. P. Huh? I heard somebody say it. L. I. M. E. Thank you! Golly, y'all got it out the first letter. What's the complement? It's what makes up the whole, right? So the whole is 1, right? So what could you do instead of adding up 4 numbers? What could you do? Subtract the top 2 from 1, and that would give you the answer also. Now, the reason I'm telling you that is not to confuse you. I'm just telling you that because you need to know the complement and how it works. You should know the complement by now. First, you can take 0.0854 plus 0.2605 plus 0.3971 and 0.2421. And add all those up, or you could say 1, because you know that y'all just said that the whole thing is equal to 1.00 because you said it checked. So we could just take 1 minus 1 cent and 49 hundredths of a cent. So that'd be 0.0149, which would be 9851. 1 minus 0.0009 plus 0.0140, and I think I came out with 1 minus 0.0149, which I think I did in my head, and I came out 0.9851. Somebody check me. That's the answer.
Yeah.
Right here. Well, golly, I added up all those in my head without a calculator. No, I didn't. I took 1 and I subtracted this. Now, which one's easier? And you don't have to depend on what. So you don't have to ask what the 6 cents for when somebody gives you 6 cents. Okay? So, this is it's counting 4 and this is 5, 6, 7, 8, and add those up. That's one way to do it. The second way is 1 minus the complement, which is 1 minus 0 and 1. And we'll put this in green. Oops, sorry. Wrong thing. There we go. 0 and 1 is what we're not looking at, so we're using that as the complement. All right, now, what does it say? The probability that more than one subject experiences headaches is 99%. So what can you ascertain about this study? That if you don't take at least 10 milligrams of the drug, you're going to get what? You're going to get a dang old headache. So, the answer is going to be yes. But let's see what our choices are. So that one's not it, and that one's not it. So, yes, because the event that the number of subjects that experiences headaches is less than or equal to 1 is not unlikely, or yes, because the event that the number of subjects is less than or equal to 1 is unlikely.
That doesn't even make sense.
No, it doesn't. Okay, let me look at that again. Yes, because the event that the number of subjects that experiences headaches hold on, yes, because the event that the number of subjects that experiences headaches is less than or equal to 1 is not going to happen. I changed that, is not going to happen. Yes, because getting a headache is going to happen. That's what that says. Yes, because getting a headache is going to happen. you have to translate these words. This is Philadelphia lawyer talking, okay? That's an old saying. Y'all ever heard that saying? That's so complicated, a Philadelphia lawyer, it's your parents' fault. Your Philadelphia lawyer couldn't understand it. Your parents' fault. So the answer is that. You've got to look at them and translate. You know it's not which ones. You know it's not A, or you know it's not B, because you got a 98% chance of getting a dang old headache right here. So you need to find the one that says, I'm going to get a dang old headache. And the one that says that, after you read it 3 or 4 times, yes, I'm going to get a headache. The chances of me getting a headache is going to happen. And that is unlikely. Or less than or equal to is unlikely. That means it's going to happen. Does that make sense? Don't worry. Like I said, I'm not going to test you. I'm going to test you on the math. I'm not going to test you on if you're a Philadelphia lawyer or not. Okay? Or why they can't. That's one of the reasons we don't use this book anymore. Or after this semester is over with. Because of these dang stupid attitude questions. Alright, let's do one more and just forget about that. Alright, try that one, and then if you can't do it, just consider yourself a failure. Okay. I'll just read it. Refer to the accompanying technology display. That's what you were asking for, wasn't you, Havana? Alright. Blah, 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 blah. Assume that 5 subjects are randomly selected and treated with blah, blah, blah. Find the probability that more than one. So we got the same type problem. I want you to do it both ways so you'll know. So you got your handy dandy, what did it say? Find the probability that more than one. So you can add up all the yellows, or you can what? Add up the greens and subtract from what? 1. So that'd be easier because that'd be 0.00 what? 75? Dang old 99.25 or 0.9925, which is 99.25. It's a miracle. No, it's not a miracle. It's just what's called using your brain. What's this? 684. Need a calculator. So we got 0.0051, 0.0551. That's 2.2124, 0.4094, and 0.3156. So if you want to add those up, you need to use your calculator. Unless you're Rain Man, you're not going to be able to add them up in your head unless you sit there for 15 minutes and look at them. Or you can do 1 minus the complement. And in this case, that would be the easiest thing because, oh well. And that would be 1 minus the complement is 0.0004 plus 0.0071. And I don't think anybody in here doesn't know what 71 cents plus 4 cents is. That's 1 minus 0.0075. And we all know that the complement of 0.0075 to 1 is what? 9925, because you know that 25 cents makes a $1, and that busts the 99 up to 1. So hopefully you know that. But anyway, if you don't, then you know what to consider. 0.9925. And if you add all those up, you should be getting that also. So 0.9925. Another good test question. Why? Because it's short and sweet. But except I don't like the stupid attitude question that comes after it. We know it's, okay, are you going to get a headache?
Yes.
Yes. So just say yes. Just put a yes down here and say yes. You're going to have a headache. No, I'm just kidding. Be easier to do that, wouldn't it? All right, so that one's out and that one's out. And then you turn into Philadelphia lawyer.
It's A because the other one's not.
Okay. Try to memorize the short one and the long one. Because all this is gibberish. Yes, because the event, that number of experienced headache is less than or equal to 1 is unlikely. Less than or equal to 1.
When you say not unlikely, that's like reversing what you're saying.
I know that, but they just make it difficult. Check answer. And we feel good about ourselves. So pick the short sentence with yes. And I know 2 or 3 others that teach 120. They'll tell you the same thing. The way they've got these things worded, it just makes you mad. All right. And we'll leave that one. And let's go over an online question. Ooh, that's 6.5. We ain't covered that yet. And 5.315/6. 5.315/6. Assume that the procedure yields. Ooh.
Yeah,
Okay.
that's what freaked me out.
Well, it's the same. You can do the same thing with. This is showing you how to use the table. And I do not have a problem with y'all learning how to use the table. It's in the back of the book, in the appendix, or one of the cards. Say one table. It's the cardboard cards that's in your book. Or just look in the back. Or just pull it up. It says, assume that a procedure yields a binomial distribution with n is equal to 8, p is equal to 0.5. Use a binomial probability table to find the probability that the number of x is exactly what? 3. So what is x? So how can you do this problem? And to use what? NPX or use the table. Well, I don't know how to use the table. Well, let's see if we can figure it out. It's so tough. N is equal to what? 8. Here's n. Reckon where we're going to go? To the 8. So you go until you get to 8. So move down. Oh, there's n is equal to 8 right here. All right. Well, n is equal to 8. P is equal to what? 0.5. So we take our handy dandy straight line maker. I can't use the. I'll just have to use this. And we use yellow. 0.5. Look at there. There's 0.5 right there. And a P right above it. And there's our line right there. And I'm going to go down. And I know I got it right beside to the right. So we got to look on the left hand side. Alright. And we go to 8. And then what are they asking? Say again. I heard. 3. N is or P or N is equal to 3. And if you look up here, what do you think's above that other column right there? If we ever get up there. Or X, I'm sorry. X. NPX. 3. So you go down. And you take your handy dandy green pen. Your green horizontal line maker. And you do 3. Oops. Wrong color. 3 right here. And it's going to move it. But just hold on a minute. I'm getting there. So what do you get when you cross the green with the yellow? 0.2190. 0.2190. So if you use the table, you get 0.2190. So we're going to put that right here. 0.2190. Now, a lot of people say, well, Hubert is going to 3 places. Well, you need to learn that areas are 4 digits, because in chapter 6, that's what I'm going to start the chapter with. Area is 4 digits. Z-scores are 2 digits.
Does that mean it bad?
Huh?
Does that mean it bad?
No, I'm just putting it down as 2.2190, because from here on out, whenever you see 4 digits or you see probability or area or percentage, you need to turn it into 4 digits. 4 digits. So 0.2190, it says round to 3, so take 1 off, just so it'll be happy. I bet we got it right. It's a miracle. And what do you do if you don't want to use the table because you're too, lazy? If you're too lazy to use the table, second function entry, and our N is what?
8.
And our P is 0.50 and 3. It's a miracle. Calculator puts up 0.21875 and round to 3, 0.219. That's a pretty good test question. Of course, somebody will get it wrong, but it's a good test question. I like, this is the chapter section. Chapter 5 is the one that I try to let y'all make 100 on, because the questions are so what? They're so easy, except for the stupid attitude questions that they ask. I don't count those anyway, but just make sure you see me if you miss one. Okay? You feel good about that now? Let's do one more, just for good practice. Alright? And I'll put the table up here, and it says N is equal to 4. You should be able to see it, and I'll blow it up here in just a second. I'm going to get this out of the way. There we go. That's going to be about all I can do right there. Maybe one more. Had to take my truck last week, get the the transmission rebuilt. Like having my right arm cut off. Can't stand it. Ride around in a little Ford Explorer type, Mountaineer type thing.
Did you get it back?
I'll get it back tomorrow morning, I think. Well, on diesels, you have a extra couple of coolers for your transmission, and on the side of the engine there is a torque converter cooler, which basically is a tube with water running around a tube that's got hydraulic fluid in it. And one of them busted, and I got transmission fluid in the water, and I got water in the transmission fluid. But it didn't mess up the transmission, it just messed up the first set of gears to make that first shift. So it got to where it was getting on my nerves. So yeah, well, no, shifting at all, I'd have to go in granny gear. Well, in the automatic granny gear, I'd have to mash the gas and get the RPMs up high, and then let off on the gas real quick, and then it'd shift. And I got tired of doing that because people thought I was going to run over them. Especially, in school zones. No, I'm just kidding. But anyway, I finally got it fixed. I hope they got it fixed. Anyway, all right, so this is N is equal to 4. So you take your handy dandy do-jigger here. N is equal to 4. Dang old right here. And P is what? P is 0.4. Sorry, I got the wrong one. .4 is right here. And green, be a highlighter there. And what is X? 2? I got .34, I can't see that. 6.346. So let's take our handy dandy computer and check it. Just so we can feel good about ourselves. Should you get this one wrong? You shouldn't get this one wrong. Because you got 2 ways to do it. Both take a little bit of work. Let's see, 4. Sorry, I had 4 flat tires. .4. And
That thing's gonna get mad because you have 2.
I know, it's going to get mad. It's going to have a fit. It's going to say error or error and comma 3. .1536. I've got something in wrong. Oh, 2. Okay. Second. 3, 4, 6. 3, 4, 6. It's a miracle. That was awful what happened in Charleston this weekend, wasn't it? Or last week, or whenever it happened. Sure did hate that.
Everybody's flipping out over the flag.
That ain't nothing but political. That's all political. They couldn't divide what they wanted. You know who they is? Politicians. They wanted South Carolina to erupt into what? Riots. That's what they wanted. Just like the other places. But South Carolina didn't do it. So, what do we need to do?
Right about what? That flag?
No, about the people getting killed. Doesn't matter. They want every state in the United States to go in riots. That's what they want.
Are we the only one with flags?
No, we're not the only one. There's 3 or 4 other states, but you know.
They've got to build another
Huh?
problem.
Well, my problem is this, and I hate it I hate it, and it happened, and I can't do anything about it. All right. But look what South Carolina did after that. What did South Carolina do? They came together. I mean, there was a lot of people down there crossing that bridge down there. There was a lot of people out there giving flowers. There were a lot of people giving money. There was a lot of people, pouring their heart out. What does that flag have to do with that? It has nothing to do with that. No, they just want something in the news. That's what they want, in my opinion. That's my opinion. Everybody's got one. I mean, that flag is like 2 hours away from Charleston. What did that flag have to do with anything? Take the flag down, racism's going to be gone.
They said it was going to be a picture of him burning that flag.
They say all this stuff. I think it's ridiculous. Let me ask y'all a question. Is taking down that flag going to get rid of all the nuts in South Carolina? No, it's not. And that's just my opinion. I got one like everybody else. You ain't going to get rid of all the nuts. Period. Hate it. Fact of life, there's always going to be nuts.
You want to bring it back down?
I mean, just like that guy, they were talking about that guy that dressed up like the Joker and went in there and shot all them people in the...
Yes.
Oh, what are we going to do? Get rid of comic books with Joker in there?
When did that happen? A long time ago.
Oh, he's still on dadgum death row or whatever. He's still in court.
When that movie, the Batman movie came out, and he shot up the movie theater.
Oh, I didn't realize
Unless he dressed up.
So we need to ban Batman movies. Because Batman movies invoke.
But I'm not kidding. Every time the lights turn on at the movie theater, like it goes out, I freak out. I'm like, oh my god, my God.
5.411/5. 5.411/5. Now remember, we're not in 5.3 now. 5.4, what do? That's dang old. NPQ. Yeah. And taking the square root. Yeah, that's it. NPQ, and then square root of NPQ. So here we go. Oh no, it's the 100 M&M question. Better get the calculator out because you can't do it without the calculator. Find the mean and the standard deviation for the number of candies in each group, or each such group of 100. So, what is N? 100. So, what is P? 0.19. So, let's take our three formulas and do the math. I thought I brought it down some more. There we go. So in 5.4, what are the three formulas I just told you? In 5.4, the mean is equal to n times what? And the variance is equal to the square root, is equal to NP what? And then standard deviation is equal to the square root of what? Variance. So really you just have to do these two. And then you just take the square root of variance. Alright, here we go. Hard mathematics. So what is 100 times 0.19? 19. Now, this one is 19. So we just got that right there, 19. Times, well, if P is equal to 0.9, then Q is equal to point what? 0.81, Hubert. That's right, class, because Q is the what of P? Complement. Learn, I didn't have to spell that time. So, we take 19 and multiply it by 0.81. 19 times 0.81. Now let's go back and let's talk about what is 10% of 19. 1.9, Hubert. That's right, class. So if 10% is 1.9, what is 1%? 0.19. So how many 10% we got here? In 81%, how many tens do you have in 81%? 8. So 8 times 1.9 is dang old 15.2. Somebody check me. Is it 15.4? Okay. I'm off a little bit. Y'all check me. And then 19 cents. Well, what's $15.40 plus 19 cents? $15.59. Y'all check me. I think I did 1.9 times 8. I thought it was 15.2. 15.39. No. What is 10? What's 8 times 1.9? That's what I was asking. I thought it was 15.2. Okay, I was right, and somebody tried to steer me the wrong way. That's okay. I know what you're doing. So then that'd be 15.39. Okay, what'd y'all come out with? Okay, so that's what? The variance. So your variance is equal to 15.3. So now what do? Take the square root of the variance. Well, the square root of 16 is what? 4, Hubert. That's right, class. So the square root of 15.4 is probably going to be about 3.9, and that's your standard deviation. So somebody take the square root of 15.4, what do you get?
I think 15.39 got
3.9. Well, what's 15.4? What's the square root of 15.4? I'm just curious.
3.94.
Okay, same thing. 3.92. I'll put a lot of these on the test. Why will I put a lot of these on the test? Because I want you to do them. I want you to do them in your head, or at least try to do them in your head, which I know one of y'all out of 15 will do. But okay, so what do we come up with? 19. And they don't even ask for the variance. 3.92. What are they going to ask now? All right, let's see what it says. Let me see what it says, and then I'll see if I can decipher it. Let me get all this out of the way. A random sample of 100 candies containing 20 orange candies, that would be 20%. Is the result unusual? Wait a minute. Random candies. It's 20%. Is this unusual? No, because it's over. Okay, they're comparing it to this one.
Yeah.
All right, so what you do.
Is this going to count?
Yeah, this one will count because this one is anytime what I tell you, anytime you got these two numbers, what should you draw?
A bell curve.
Bell curve. And dang old 19 and 4. What's 19 and 4? 23. And 23 and 4 is 27. 19 minus 4 is 15. And 15 minus 4 is 11. So you buy a pack of candy and you got 20 orange candies. So what is that? Is that normal or is that unusual? Normal. So what does it say? Is this result unusual? Yes or no? No. So you automatically take out those. Then you say, oh my, the answer is no. Now this one doesn't take any deciphering. This one, you just got to draw the bell curve. And 90% of the time, if you have a question and it's asking you for these two numbers, they're going to follow up with a bell question curve. Bell curve question. Bell question curve. All right? So we feel good? That one's 23. Let's go ahead and do one more. It is test day. I mean, I have assigned the test, so did we go through the test?
No, you said you didn't want to go.
Yeah, it would. I'll go through it and let you see it. How about that? We're not going to work it because I think I've already worked half of it today. Just like gun control. I'm sorry. Taking away guns is going to do away with murders, like taking away forks is going to do away with fat. Honestly. Better take away them knives too, because how can you kill somebody with a knife? Stab them. Gotta take away them bow and arrows. Gotta take away them rocks too. People can die from getting beat on upside the head with a rock.
Cars.
Yeah, gotta take away cars, car control. I can lay a .45 caliber pistol on this table right here. How many people will it kill? None. How can that gun kill somebody? Somebody's got to pick it up. Same thing with a fork and a car. Fork ain't gonna kill nobody as long as somebody don't pick it up and stab you with it. I'm sorry. I just think some of these things that these politicians come up with, I think they're stupid.
I think what they're trying to say is more like gun control, not elimination. They're trying to say like people should be able to get their hands on it.
You're talking about 70%. Yes. But you got the right-wing nut jobs that believe you got to put away an arsenal, and then you got the left wings that want to do away with it.
Right.
And that's the ones that,
There needs to be a balance.
yeah, but there isn't. Get rid of guns. That guy wouldn't have killed those people if you didn't have guns. Whatever. What do you think people's going to do when you get rid of guns? They going to find something else? Are they going to make their own gun? Or are they going to go over to Russia and buy them? I mean, it's ridiculous. All right, so dang old mu is equal to 100 times 0.23. Look at that blazing calculating skill I got right there. My variance is equal to 23 times, what's the complement of 23%? Dang old 77%. Dang old 10% is 2.3. Dang old 1% is 0.23. So 2.3 times 70 is dang old 16.1. And dang old 23 cent added 10 cents, 16.33. Somebody check me. And then the standard deviation is square root of 16.33. Somebody help me out. I need to calculate that because that's some rough stuff right there. Check this, please. What's 23 times 0.77? Okay, see, I got it. I did something wrong. Hold on, let me figure it out. Oh, I forgot to add the 7. Oh, I'm sorry. Dang, my mistake. 7, I forgot. I did 70%. That's what I did. No, I did 71%. I forgot to do the 7. So 7 times 0.23 is $1.61. $1.61. So $1.61, and that's going to give me. Hold on a minute, and I'll ask you if that's right. 17.71. And then 17.71 is going to be about 4.2. People, I don't want you to be Rain Man. I just don't want you to look like a fool when somebody asks you a simple math question in real life. That's all. You know, somebody asks you what's square root of 26. Please don't put that in your calculator in the real world. At least I can say you learned that out of my class. All right, 4.2. And that way you can make fun of people that say, what's this 6 cent for? You can make fun of them. All right, 23. Should they be made fun of? Yes, because they shouldn't be running the cash register. Why? They don't know how to do simple math. Let me ask y'all a question. If you were a business owner, let's say you own Mom and Pop's Hardware. Mr. Bright, let's say you own Mom and Pop's, Mr. Bright's hardware. Would you hire somebody to run your cash register all week and they couldn't add? I wouldn't. Why? Because you're going to have to stay with them an hour after work, try to figure out what? Why the cash register's coming up short or too much or whatever. That's why. And if anybody ever worked in retail, you know what I'm talking about. Because you have to make sure that that cash register, what? It comes out even. I don't know how to do it because I never did. I just remember watching cashiers when I was a stock boy at Walmart. I used to have to do that. Ooh, I can't handle that. Too much work for me. Too tedious. So 23, check answer. Look, we got it right. And the variance is 4.2. That's a good question. Oh, they're going to ask something else. Oh, yeah. So let's look and see. It says a random sample, you bought another pack of candy, and it had 37. So that's 37%. So is 37, well, 23 be 20, 23 plus 4 is what? 27, and 27 is 31. What did they get? 37. Is that unusual? Yes. So you take out the no, and now you say minimum no, within no, greater. So you D. You see why this one is not like the other ones? It's not like the other ones because you can actually answer this one if you draw your bell curve. Okay. All right, let's look at your handy dandy test. As soon as I can find it. Let the random variable x blah 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 blah. This is one of those in the first where you got to find the mean and the standard deviation. So go ahead and work on it. This is where you do the columns. X, p of x, you got to get x times p of x, and then x squared, and then x squared times p of x. So get to it. I'm doing this one because we haven't done a homework problem like this one today, so I thought I'd do this one. I'm going to put it in the spreadsheet. Not that you have to use a spreadsheet, but it's a whole lot easier for people to see on the screen when I do the spreadsheet. Assume the probability of a child being 0.32. The table on the right describes the probability of having X number of girls. Determine whether the table describes probability distribution. If it does, find the mean and standard deviation. If it's unusual, blah, 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 blah. Is it unusual for a family of 3 children to consist of 3 girls? So that's 0.03. So I'm going to take my handy dandy spreadsheet. And then I'm going to put x times p of x right here. And then what? X squared, Hubert. That's right, class. And then what? X squared times p of x, Hubert. That's right, class. Y'all are so helpful and interactive. I appreciate it. So here's the first one. This times this. Copy that down. And then I'm just going to go ahead and do everything first. And this raised to the what? Second power. And then x squared times what? P of x. Which ones do we total up? X times P of x. And when we total up x times P of x, what does that give us? The what? The mean. Good job. Hopefully by the end of the semester y'all be talking to me. What else do we add up? X squared times P of x. But that's not anything, we're going to use it in the formula. And the variance is equal to, what's the variance equal to? You got to take this number right here, 1.577, and subtract what? The what? Mean what? Squared. And then what do we always do to the variance to get the standard deviation? Take the what? Or raise it to the what? To the 1/2 power or 0.5 power. Oh, that didn't work. Shift 0.5. Let me check that. There we go. Now, of course, we're going to take that, and our mean is what? 1. I'm just going to use 1 as my mean because I don't want to add decimals. And then 0.8, that's 1.8. And then 2 point what? 2.6. And then 1 minus 0.8 is 0.2. 0.2 minus 0.8 is negative 0.6. So is 3 girls unusual? Okay, that's a no or a yes.
No.
Is 3 girls
No.
unusual? Yes. Because it's outside of what? 2 standard deviations. Because 3 would be where? Right here. And here's your, let me just do this. Oh, that sucks. Well, that really sucks. But anyway, you get the point. Where's 3? Well, you take your handy dandy red marker. 3 is out here. And 3 is outside of what? 2 standard deviations, which is normal. So it's out here. So let's go back to the question and see what the heck it asked. What was our mean? Point what? 0.96. What was our standard deviation?
0.808.
0.81. Is it unusual?
Yes.
Yes, it's unusual because it's greater than 0.05. It goes outside the BC. Okay? Question. All right. Next question. That's a gimme question. All right, try that one. We didn't go over one like this. When somebody buys a ticket for an airline flight, there is a 10% probability or 10% chance that the person will not show up. Will not show up. So what is the probability of somebody showing up? Dang old 90%? Yeah. You need that, 0.9, whatever the complement is. A certain jet can seat 17 passengers. You with me? Is it wise to book 19 passengers? I don't care about that. Just tell me what is the probability that all 17 seats are taken? NPX. Will you wait a minute? So take your handy dandy calculator and somebody tell me what N is. Well, N's going to be 17 because what does the jet hold? 17. So and what's the percentage that they're going to show up? 0.91 9015. Thank you. So that'd be 0.90. Dang old insert 15. What'd I say? 0.901 what? 5? Yeah. And then what did I type in here? Well, we want the probability of the plane what? Filling up, Hubert. That's right, class. So what would that be? 17. I get a 20% chance. 0.17 or 17% chance, I'm sorry. 0.1716. So what do they ask? 0.1716. It is a wise decision because the probability is not enough seats on the jet is whatever. Point what? What did I say it was? Point what? 0.1716. I don't know. I don't know yet. Now I do know that in one question we did, I don't know if it was homework in here or a test question, it was like 98%. That would not be a wise decision to book 19 because whoever booked it is going to have to deal with them when what? When they all show up, because you got a 91% chance that they're going to show up. But the way the probability works out that all 17 will show up is what? 17%. So it probably is a wise decision, although I wouldn't overbook, period, because I don't want to have to deal with the people fussing if they all show up. So I wouldn't.
Does this have to do with that 5% rule?
Hmm?
The 5%?
No, they're just asking, is it wise based on the probability? And you would say it is not wise. I mean, you wouldn't say it is not wise because that is if it was 98%, then you'd say it is not wise because you don't want to have to deal with the people when they're fussing. So you know it's not wise. So that one's out and that one's out. It is a wise decision based on the probability that there are not enough seats on the plane. So overbooking is not a what? Unlikely a bit. And this one says, so overbooking is a what? Unlikely event. Overbooking is when you have too many. Okay, so is not is an unlikely. No, overbooking is an unlikely event. This means is not an unlikely event means that overbooking is going to happen. So why can't they put so overbooking will happen? I don't know why they can't put that. But anyway, so that's that. Next question. NP and X, I'm not going to do those. Now, what is the problem here? What happens?
You don't put them in order.
You don't put them in order, and y'all get an error or an error on your calculator, and y'all go into convulsions. I'm not going to address that because I've addressed it how many times? At least 5 or 6 times in class, that you have to take that X and put it where? On the end. So when you write this on your notebook paper doing the test, don't write NXP, write what? NPX. Because if you type it in NXP, you're going to get something crazy and you're going to go into cardio infarction or whatever it's called. All right, that's the TV show problem. I know we did one of those. A certain TV show recently had a share of 80, meaning that among TV sets in use, 80%, there's your P, turn to that show. Assume that an advertiser wants to verify that 0.8 is the good probability by conducting its own survey, and a pilot survey begins with 9 households. So what do you think 9 is? What's the largest number always going to be? N. Yes. But that leaves X. I don't see no other numbers in the top portion, so that means X is going to be where? In the A, B, and C. Okay, so A. Find the probability that all the households, what would all be? What would X be? 9. So that would be NPX, 9.8 and 9. Somebody tell me what you get. 3 decimal places. 0.134. Find the probability that exactly 8 0.302. And find the probability that at least 8. Now, what does at least 8 mean? That means the lowest number is what? 8. So what does that mean? At least 8 means 8 and 9 are not included. At least 8. All right? Okay, at least 8, yeah. So you could either do the complement of 1 and take away the, let's see, which one? Let's see, the probability of exactly 8. No. Okay, 8 and 9.
So you just add
Yeah.
those 2 numbers.
Add those 2 numbers and subtract it from 1, and that's going to be 0.436.
Why would you subtract it from?
Okay, that's because you got to know what at least means. If you don't know what at least means, then you don't understand it. At least, I don't even know how to do that. At least 8. What does that mean? Well, let's draw a number line. And where does it start with? 0, because there can't be -5 out. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so there's our set because we don't have 10 houses and we don't have negative houses. All right, so at least 8. So what does at least 8 mean? That means your lowest number is what?
8.
So that means we're covering this one and what? This one. So the question C is talking about these 2 houses. At least 8 means these 2 houses right here. So you can find the probability that they're at least, so you add those up. Yeah, you're right. You add those up.
You don't subtract.
You don't subtract. Now you can take all of these, which would be a pain because you'd have to do it 7 times and subtract it from 1. Or you can just take 8 and 9 and add it what? 0.436. So you were right. I thought you were asking something else. 0.436. And then if at least 8 households are tuned to the TV show, does it appear the 80% share is wrong? Well, if at least is what? 44%.
Then yeah, it's wrong.
I would say it's wrong, but I get this question wrong all the time, so you figure it out. So it's not going to be no. So I got 44% and they got 80%. Why or why not? Well, first of all, I don't know what a share is. It says a certain TV show recently had a share of 80%, meaning a share of 80% means that it's 80%. Well, it looks like to me it's high. It's wrong because ours is low and theirs is high, but I don't understand what they're asking.
So it's not unusually high.
Does it appear that the 80% share is wrong? Yes. It's wrong. I don't know about this other stuff, but yes, it's wrong. Because 8 households tuned to the TV show is not unusually high. I'm going to say it's this one
Yeah.
because ours is 44%. How much confidence do I have in this? None. Because I don't understand half these questions. All right, next one. And that's a problem that I'll look over. I want you to get these 3 right here. Okay? Next question. There we go, another MPX. That's the one we did. Now you could do it in a calculator, but make sure you know how to do both. N is equal to 2, P is equal to 0.3, and X is equal to 1. So 2, 1, 0.3, 0.420, is that what y'all got? And you feel good about yourself. I didn't want this question on there. Okay, I'll give y'all this question, but I'll show you how to do it. This is fairly an easy question. Find the probability of exactly 3 Mexican Americans among 12 jurors.
So 0.054.
That's it. 0.054.
For your fear, you guys.
Okay, 3 or fewer. That means 3 is the highest number, right? So that means 0, 1, 2, 3. So let's do this. Okay, 5 cents plus 1 cent is 6 cents. Plus this, that's 7 cents. So that's going to be 0.073. I got 0.073.
That's where it makes no sense.
This is asking you to be God, basically, because relevant. It's relevant. Which probability is relevant for determining whether 3 jurors among 12 is unusually low? The result from part A? Well, exactly 3. I would think it would be this one. Because how many are on the jury? Exactly what? 3. So I would say A. Oh yeah, thank you. I meant A up here.
Yeah.
Is 3 unusual among 12?
Well, it's only 70%.
Yeah, 7 is more than 5, so it's normal. So where does it say that? Well, unusual would be no. It'd be yes because it's greater than what? B? Is that what you said? Is that it? Okay. Next one.
Wait,
What?
it's not an unusually low number. So the answer would be no.
Probability is relevant. Okay, hold on. Is 3 unusual? And we said no.
That's a complete yes.
Oh,
So it's really no.
greater. Thank you. Because it's greater, it's 7%.
Yeah.
Okay, sorry. So you gotta be careful.
Really.
I'll be lenient on that one. Okay, 8 was a give me, 9 is a give me, 10 is a give me. It's not supposed to bunch them up like that, but all right. 5 males with a particular genetic disorder have 1 child each. The random variable X is the number of children among the 5 that would inherit the gene disorder. Determine whether the 4 table describes a probability distribution. First of all, what you got to do? Check to make sure each one of them is between what? 0 and 1. Then what you have to check? So do that. This is another 5.2 question where you got to find the mean and the standard deviation. Did y'all check it? I mean, add it up right quick. Okay, thank y'all. Appreciate it. It's always good to have a class to back you up, not leave you hanging. So X times what? X times P of X, Hubert. That's right. And then X squared. And then what? X squared times P of X. X times P of X. And then X squared, which you could do that in your head. I don't know about that. I better not say that and cover everybody. Somebody will probably mess it up. And then X squared times P of X. And then which one do we add up? The mean is what? X times P of X. And then we just add this one up. Just add it up. And then the variance is equal to this minus what? The mean squared times 2. Your failure. And that's your variance, and then your standard deviation is that raised to the what? 0.5 power, Hubert. That's right, class. So our mean is 1 and our standard deviation is 1. So you got 1 in the middle, then that'd be 2 and what? 3. And of course that'd be -1 or 0 and -1. And of course you can't have -1 babies, so 1, 2, and 3. So in this case, well, you need to add, somebody add 1.15 plus 9.4 and then add 9.4 again to it. What do you get? It should be over 3. What do you come up with? Huh? 3.09? 1.15 plus 0.94 plus 0.94. Okay, so 3 is normal. So 3 kids would be normal, 3 babies would be normal, because this came out to be 3.03. So 3 would be normal. You could say 3 is normal. Let's see what the question asks. It's probably going to ask for their names and addresses. Anyway, what is our mean? 1.14 or 1.15? Our standard deviation. Okay, so that'd be 1.2. Okay, thank you. And then standard deviation is what?
0.9.
0.9. That's all they ask. 14 Ps are generated from parents. We did this in class. Having the green yellow pair of genes. So there is a 0.75 probability that an individual P will have a green pod. Find the probability that among 14 offspring, 14, no more than one. What does no more than one mean? That means your highest number is what? 1. So that means 0 and 1. So X is going to be 0 and X is going to be 1. This is just like the homework problem we did where you'd have two NPXs, and what do you do with two? Add them together. So do NP, so do N 0.75, 0, N 0.75, I'm sorry, N is what? 14, 0.75, 0, 14.75, and 1. And add them together. Somebody tell me what y'all get. Well, I better do it. Somebody will lead me astray. I done learned my lesson with y'all. So 14. Point 0075. Oops, no, that's not right. 0.7500. And 0, 0. All right, there's that one. So I'm going to store that. And then second function entry, second function entry, and the same thing except this one's going to be 1. And add that. That's going to be stow alpha S for second number. And now alpha F plus alpha S equals, I got 1.6. It says round to 3 decimal places, 0.000. That's what I get. Is it unusual? Yes, because it's what? Yeah, it'd be C. Next. That's okay. All right, 5 male. Did we already do this one? Oh, well, I gave you 2. Okay, so I'm not going to do it again, but I didn't know I gave y'all 2 freebies. Oh, well. Ted is not particularly creative. He uses the pick. Oh, he uses the pickup line. If I could rearrange the alphabet, I'd put U and I together. The random variable X is the number of girls that slap Ed upside the head before encountering one who reacts positively. Determine whether the table describes a proportion. Let's see, 0, that's 2 cents, that's 14 cents, that's 36 cents. 30, it's not. So I need to take that one off, don't I? Oh my gosh, there's another one. NPX. Don't put it out of order. There's that Lindsay and Tobias question. We already did one like that. That's that dang old share. I'll be lenient with your question down here. NPX. All right, that's 3 questions that y'all should get right. 3 questions there, and then 13 questions. I think there's 13. So So that's 13 of 16 questions. People, y'all better not fail this test. All right, questions. I failed.
See what number 5 was? Yeah.
Number
You
5?
got it wrong.
Yep. Told you I would.
No.
Oh, the 80% share is not wrong. I don't understand what a share is then. So, but we got everything else right, and that's all I care about with y'all. All right, y'all get out of here. Have a good day. Oh, I got to take the roll. Thank you. Roll. And we'll start chapter 6 when y'all come back. Chapter 6 will be real quick. It's not going to be, and it's easy too. Unless y'all want to make it hard. 5 and 6 is the easiest sections.